So let's begin. Today's topic is about the number representation and how to convert from one form to another form. I will share my screen. Okay, so let's begin. The first type is converting binary to a denary number or binary or a decimal number, all are same. So converting a binary number to a denary number, binary will have only two values. One is 0 and the other one is 1. So the given value is 00110100. So this binary value has to be converted into a decimal value or a denary number. So for that, let's construct a table first. So in the table, we are going to have all the numbers which are obtained by the increasing power of 2. So for example, 2 power 0, well, let's start with the first number. 2 power 0, that is equal to 1. So that is our first value here. Okay, we can see that here. And then we have incremented the value. Next we have got 2 power 1 is equal to 2, and then 2 power 2 is equal to 4, 2 power 3 is equal to 8, then 2 power 4 is 16, 2 power 5 is 32, and 2 power 6 is 64, and 2 power 7 is 128. Okay, so we are going to maintain a negative symbol for 128 so that it will be applicable for the negative numbers as well. Okay, so now we are going to place the values according to this number because it's an 8-bit binary number. Place the values correspondingly. Okay, so starting from the left hand side or starting from the right hand side, you have to place the corresponding values. So we have 00110100 according to the given question in the same order. Now we are going to consider only the columns which is having 1, not the ones which is having 0, because anything multiplied with 0 will be equal to 0. So we are going to take only the columns which is having the value 1. So we have 32 with the value 1, then 16 with value 1, and 14 with value 1. So we are going to multiply that with 1, and corresponding values are 32 plus 16 plus 4. Add up all the values and we're going to get the answer as 52. So the given binary equivalent in denary is 52. Okay, so conventional base, when we are going to represent it, we can represent it as base 2 and base 10. Okay, so let's do another question. 0101110. So place it accordingly. Now consider only the ones with 1. So it would be 64 into 1, 16 into 1, 8 into 1, and 2 into 1. Add up all the values, it will make up a sum of 90. So that is the corresponding denary value. Okay, next we have 1101010. So place it accordingly. Now we can come to know that it's a negative number because it is having 128 here. So 128 is also mentioned as 1. So when we are multiplying the corresponding values, we will get it as minus 128 plus 64 plus 16 plus 8 and plus 2. Add up all the positive numbers and subtract it with 128. We are going to get the answer as minus 38 and maintain the negative sign as it is. Okay, because this first bit will usually tell us if it is a positive number or a negative number. In the previous two values or the examples that we have seen, the first bit of the given binary value is equal to 0. So we can say that it is a positive number. Now the first bit value was equal to 1. So it is definitely a negative number because that will represent the sign bit. Okay, so maintain the negative symbol as it is and we are going to get the answer as minus 38, and representing it in terms of binary and denary, we have got this equivalent. Next value 0 and 7 times 1 we are having. So after placing it, we know that it is a positive number because 128 is not considered and the first bit is equal to 0. Okay, next once we add up all the values, we are going to get it as 127. Okay, so it's the corresponding denary value. Similarly, if this value is taken, which is binary value 1 and followed by 7 zeros. 1 is the sign bit, so it is a negative number, so we are going to have only 1 in it, which is 1 minus 128. So minus 128 into 1 is equal to minus 128, and that's the largest number that we have seen in the table, right? So this is all about converting from binary to a denary number. Hope it's clear. Next, converting from denary number to a binary value. So both, it can be both positive or it can be a negative number. So let's go for a negative value, because that includes how we are going to do for the positive number as well. So minus 44, if we are going to take, we'll let have a skeletal table with the same values: minus 128, 64, 32, 16, 8, 4, 2 and 1, because we are going to represent it in binary format. Okay, so let's start with the leftmost value, which is 128. So keep the minus sign as it is, and then add the next number, which is 64. So once you add it, you will come to know that you are getting a negative value, but it's a larger number, so we can still add some positive numbers so that we can subtract the values, and finally we can get minus 44. In the same way, when we keep doing it, after 64 we have 32. If we are going to add 64 and 32 and subtract it with 128, the answer is minus 32, but that is very less when compared to 44. So what we will do, we'll just backtrack. We'll remove this 32, make that as 0, and then we'll go for the next number, which is 16. Try to add that number. So if it is less, then try to add the next number as well. So in that way, when we do, we get the answer as minus 40, but that is too low when compared to minus 44, correct? So it is not matching. So that is why we will eliminate 8 by using backtracking, and then we are going to mark that as 0, and then the next number will be considered, which is equal to 4, which makes up a total of minus 44. So to which all number we have considered in this equation here to get the value as 44, only under those particular numbers we are going to place 1, and all other values will be equal to 0. So minus 128 will be equal to 1, then 64 will be equal to 1, 16 will be equal to 1, and 4 will be equal to 1. Remaining all values are equated to 0. Now this would be the corresponding 44 in binary. Okay, so it is 1 1 0 1 0 1 0 0, which is represented as a binary number, and that is equivalent to the denary value of minus 44. Okay, let's see another example. Minus 49. Okay, we'll follow the same method. Starting with 128, add up the next number 64. Then if we try to add 32 or 16, the value would become too low. So that is why we have eliminated those two numbers. We have got the value as 8, 4, 2 and 1. So that makes a total of minus 49. Okay, so next value, let's take up minus 77. Now when we take up minus 77, first let's take up 128 and 64, and that would be giving the value as 64, which is very which is not at all matching with the 77 which is given, right? So we are going to eliminate this. We are going to move to the next number. So we'll have 32 and 16 and 8, total making up to 72, minus 72. So this is also not matching. So what we will do, we'll backtrack, remove 8 and place 4, then 2, then that would make up a total of 74. So again backtrack and remove 2. Okay, and then we have 128, 32, 16, 4 and 5, that would make up a total of minus 75, and again backtrack. So even after backtracking, we'll remove 1. Even after that, we don't have any other number to be considered, so we will leave that. We'll go for 4, we'll backtrack and remove that 4 as well. Okay, eliminate 4, and what is left out after 8, we will just add the smaller numbers, which is 2 and 1 together, so that would make up a total of 77. So this is a very tedious method that we keep eliminating or trying to do the calculation, and sometimes it might go wrong trying to figure out what may be the possibilities of the given zeros and ones. So Finally, we have got this answer for minus 77 as 101100011. But we have another method that is very simple and easy to understand as well. So that would be using the 2's complement. So let's solve the same number, which is minus 77. We would get the same answer, which is 101100011. Okay, but with the 2's complement method. In this, what we have to do, whatever number they have given from the question, convert that as a positive number or consider only the positive part of it. So just ignore the negative sign as of now. We are not leaving it from the answer, we are just ignoring it for the time being. So we'll make that as a positive number, which is 77. And after getting a positive number, we'll follow the same method. Like we'll leave this minus 128 because that is not required. We're not subtracting any value because that would even give the sign bit value. So our sign bit would be equal to 0 because it is a positive number. So 128 would be equal to 0. So we'll leave that. We'll start with 64. Add up all the values, which will make up a total of 77. And that would give us the answer of 64, 8, 4, and 1, making up a total of 77. Mark that as ones which you have considered in this equation. Okay, remaining you mark it as 0. So we will be getting it as 0 1 0 0 1 1 0 1. And after getting this would be the corresponding binary value. We are going to find out one's complement. In one's complement, what we are going to do is whatever 0 is there, it will be converted to 1, and whatever 1 is there, it will be converted to 0. Okay, so we are going to take the opposite values. If it is 0, it becomes 1. If it is 1, it becomes 0. So the corresponding binary value that we have obtained for 77, its corresponding ones complement is 1 0 1 1 0 0 1 and 0. Right now, to this ones complement, the value which we have got, we are going to add 1 to it to get the 2's complement, because the method that we are going to use is 2's complement, right? So we are going to add 1 to it. Okay, so once we add 1 to it, the other 7 bits would be equal to 0. So we can write it in this way, or we can just write plus 1 as it is, if you have no confusion. So it's, if you write these zeros, then it would become a clear picture for you to what is being added. So better to write like this. So you have to remember that in binary addition, 0 plus 1 or 1 plus 0 will be equal to 1. Okay, so when opposite values are added, we are going to get the answer as equal to 1. But if same value is added, like suppose if it is 1 and 1, the answer will be equal to 10. Okay, so 0 has to be written in the answer and 1 has to be carry forwarded to the next number. Okay, so that has to be added. This you will have to remember. And sometimes there are possibility that overflow might happen. That means at the end you will be getting the solution, but one will be carry forwarded to the number which is not at all there in the range. So that is called as the concept of overflow. So there are very less chances that will happen for the conversions questions. Okay, but usually there is a possibility of overflow. So now after adding 1 to it, so let's see, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, and 1 plus 0 is 1. Okay, so you can see that the answer that we have obtained here, the first bit is 1. So that means it is a negative number. So we have got the answer for minus 77. So this is the corresponding value. Now you can check with the answer that you have obtained in the previous method and the answer you obtained using 2's complement, both are same. Okay, so this is how we are going to get the solution. So especially this 2's complement works when the number keeps on increasing. For smaller numbers, it is easy for you to do with the previous method, but for larger numbers, it is good that you go for 2's complement. And in most of the question papers, they would have mentioned which method you have to use for conversion. Okay, so usually the 2's complement will be mentioned in the question, so you will have to adopt this method. Okay, So what is the steps that you will follow? Any negative number that you have given, convert it into positive number, and after getting the positive number or assuming the positive value of it, we are going to get the corresponding binary number of it using the table. Okay, and after getting the binary value, find the ones complement. That is, you are going to convert all the zeros to one and ones to zero. Okay, opposite values. And after getting the ones complement, add one to ones complement, so that you will get the answer in two's complement. And be careful when you are doing the addition. Okay,